Okay, welcome to video lesson number 3, where we're going to review how to do dimensional analysis. Now, dimensional analysis is a systematic way of solving problems where we use the dimensions or the units to help us solve the problem. Now, there are 4 steps. We always want to identify the given and unknown units. Number 2, we want to pick our conversion factors, or these tools we talked about, and plug them in. And then we're going to cancel any units that we can. 3, we're going to plug in the numbers. And lastly, we simplify. So let's see a couple examples in action. First one, we're going to convert 783 grams to kilograms. So we're going to underline, right, what is given. That is the given unit, 783 grams. And then we're going to circle what we're trying to figure out, in this case, kilograms. Now, I offered you the T-chart as a way to organize your information and make sure you keep the numerators and denominators straight. So we put the given always on the left side of the T-chart, 783 grams. And then the unknown unit goes on the right after the equal sign. Okay? That gives us a target for what we want to shoot for. So this is the direction we're going. We're going to have that in mind, and it also ensures that we don't ever leave off the units of an answer, because that, of course, would be wrong. We always have to have units with our numbers. Okay? Now, at this point, I want to go to my conversions toolbox and pick a tool that would work. So if you look on your paper there, you can see that there are 1,000 grams in 1 kilogram. Okay? So we want to pick that tool and we want to plug it in. Now, we can also derive that tool from the units here by placing whatever is given on the bottom and then the unknown unit that we're shooting for going on top. Okay? So that's what I mean by picking the tool. So we can go from grams to kilograms. We can then cancel the grams. Okay? And now step 3, we go back and plug in the numbers. So 1 kilogram is 1,000 grams. And now I'm all set to simplify. Okay? So 783, remember that means we go across, that's multiplication. So times 1 is just 783 and divide by 1,000. So you can do that on your calculator. If you're tracking with dividing by powers of 10, it's 3 powers of 10 or 1,000. So that means I just move the decimal 3 places to the left. So my answer in this case would be 0.783 kilograms. Okay, in my next example, we're going to convert 5 gallons to milliliters. So identify the given, in this case 5 gallons. Again, the given will always have a number with it. The unknown says how many or find or something like that. So in this case, milliliters. Set up your T-chart. Organize your information. Given always goes on the left, unknown on the right. Okay? Step 2 is to pick your tools and cancel. So you're going to go to your toolbox, find a tool that gets you gallons and milliliters. There is no tool, okay? So we could just put gallons down here because we know it's going to be gone, but we can't put milliliters on there because we don't really have a conversion on hand. So what can I get instead? Okay, what can I trade for, or what can I exchange my gallons for that I know? Well, I do have a conversion that gets me liters. So gallons to liters. Notice I can plug in my numbers right here. 1 gallon is 3.8 liters. So now I've got liters. Now I want milliliters. So I'm going to draw a line separating those fractions. And now I'm going to continue with my dimensional analysis. So liters going down here. To get rid of them, milliliters on top. Do I have a tool in my toolbox? Do I know a conversion that allows me to go between milliliters and liters? And the answer is yes. 1 liter is, of course, 1,000 milliliters. All right? Now, if I've done this correct, this unit right here at the end will always match this unit right here. And it does. We've got milliliters. I've plugged in the right numbers, assuming in the right place. Now I just simplify. Go ahead and multiply everything on the top. You can use a calculator. 5 times 3.8 times 1,000 will give me 19,000. So I'll write that in there. Notice I'm dividing by 1, so any number divided by 1 is that number. Okay, last example. How many seconds are in 1 year? Okay, same approach. I identify the given, 1 year. What's unknown? Seconds. Set up my T-chart. 1 year. Over here I've got seconds. Now you probably already can tell that this is going to take several steps, so let's go for it. Year goes on the bottom. I don't know how many seconds are in a year, but I do know how many days are in a year. Okay? There are 365 days in a year. Now I'm going to hold off by putting those numbers in right now, just to show you another way where you just write out the dimensions, and then we'll go back and plug in the numbers. So if I do this, I cancel and I got days. Days are not seconds, okay? But I probably do know how many hours are in a day, right? 24 hours in a day. And hours aren't seconds. Let's get rid of hours. Hours down here, I probably know how many minutes are in an hour. You can tell we're getting closer. And then last but not least, don't have a ton of room here, minutes and seconds. Okay, so that was 1, 2, 3, that was 4 steps. Okay, so we can convert basically to anything as long as we have the right tools on hand. So notice that my seconds match there, so I'm all set. Now I got to go step 3 and plug in the numbers. Now the reason I like this is because sometimes when we try to plug in the numbers as we go, we put the numbers in the wrong spot. So sometimes it's just helpful to just deal with the units and then go back and plug in the numbers. Okay? So again, 1 year is 365 days. Of course, there are 24 hours in a day, sorry. We've got 60 minutes in 1 hour, and then we got 60 seconds in 1 minute, okay? And again, in this case, we do have just multiplying the top, okay? Dividing by the bottom is just by 1, so we can just power that out on our calculator. So 365 times 24 times 60 times 60, okay? So we get a big honking long number here. So how many seconds is that? I'll write it down here. 315,360,0. We'll put that in there like that. So that's 31,536,000 seconds. Now just for fun, let's go ahead and put this number into scientific notation. So remember, if it's in scientific notation, we can only have 1 digit in front of the decimal point. Okay? So that means it's a number between 1 and 10. The decimal point is really right here. I need to move it right here between the 3 and the 1. Okay? Now I'm also going to round it to 2 decimal places as I do that. So it's going to be 3.15 times 10 to some power. Okay? So if the decimal is right here, that would be 1 place, 4 places, 7 places. So it's times 10 to the 7th. 367, just double checking that. So 3.15 times 10 to the 7th, and of course that is seconds. Okay, so hopefully that was helpful. A lot of students have trouble with dimensional analysis. Hopefully this video is helpful. You can go back and practice the problems, and I'll see you in class next time.